Hello, this video is going to discuss equilibrium in the markets for goods and services, and in this video we'll be deriving the IS curve. This video is part of chapter 12, part 12.1. Now we just finished with part 1, the preliminary material, so now it's time to move on to part 2, the spreadsheet-based explanation of the IS curve. If you have a look at this diagram, this is the familiar 45-degree line. On the vertical axis, we have the elements of aggregate expenditures or aggregate demand. On the horizontal axis, we have the output gap, what we produce, and we know that to be in an equilibrium, this line here, whose slope is 1 minus the marginal propensity to save minus the marginal propensity to import, we know that this line has to cross this line along which output is exactly equal to expenditures, or I should be more precise, the non-structural element of output, the output gap, is equal to the sum of the non-structural expenditures. So we have the equation here. This should be familiar to you. And instead of calling this case base and alt 1 and alt 2, we'll just call them A, B, and C, and you'll see why in a second. Under case A, our interest rate, our real interest rate, is at its natural value. We have the natural value down here, and that's 2.8%. So this is where our output gap is equal to 0. Should mention that there are no demand shocks. If we have an increase in the real interest rate of 100 basis points from 2.8 to 3.8, what's that going to do to expenditures? As you can imagine, expenditures will decrease, and much as in the case with autonomous shocks to aggregate demand that we studied previously, will have the ripple effect. We'll have a first round effect, and then a second round effect, and a third round effect, and ultimately the impact of the increase in the interest rate will be magnified, and the aggregate expenditure curve shifts down from this solid red line to this dotted red line, and equilibrium output goes down from point A to point B. Now we're going to have the reverse. We're going to have a decrease in the real interest rate. So that's 1.8%. So again, everything's symmetric here. It's a 100 basis point change. And that's point C. You can see that the decrease in the interest rate caused people to spend more investment, more consumption, rippling through the economy after several waves, and ultimately we get from point A to point C the new equilibrium. And we can see kind of with our multiplier effect here, we're going to have a numerator and a denominator as we did before. So we have the output gap. In the case of the output gap, it turns out that when we raise interest rate, the output gap falls from 0 to minus 0.91. If we reduce interest rates, the output gap rises from 0 to 0.91. Well, now we're going to summarize these 3 points in terms of output gap and interest rate, because you'll remember that at point A, the interest rate was 2.8%. For point B, the interest rate was above at 3.8%, and below, when we reduced interest rate to 1.8%, we were at point C, and the output gap increased. So we can see that we have an infinite number of points that link up interest rates and output, and we can see that it's a declining function because we can see that when interest rates rise above their natural value, people cut back their consumption and investment expenditures, and when it falls below the natural rate, people expand their consumption and investment expenditures, and those ripple through the economy, and that rippling through the economy is reflected in this curve, this equilibrium curve, and that's what we call the IS curve. What happens if we have shocks to aggregate demand? Let's suppose that the government decides that it wants to spend less. or households decide that they autonomously wish to spend less, or firms decide that they wish to spend less because they're worried about future profits. Let's call that a minus 1% shock. You'll see that this is going to mean a reduction in output for every interest rate, all else constant, and that will mean a shift to the left of the IS curve. In the other direction, what happens if we have an increase, an autonomous increase in expenditures? So, for example, let's suppose that consumers decide that the probability of being unemployed is lower, so they spend more, they become more optimistic, or firms become more optimistic. Or let's say that the government is in the middle of an election year and it wants to buy some votes. Not to be too cynical here, let's call that a 1% increase. In that case, the IS curve shifts from this solid red line to this dotted red line. So what have we done here? We've derived the IS curve using the multiplier analysis that you learned in a previous chapter, and then we've also shown why the IS curve might shift, and it turns out that if we have autonomous shocks to aggregate demand, if we have a decrease, we'll have a leftward shift in the IS curve, and if we have an increase, we'll have a rightward shift in the IS curve. People still probably want to know, where does the name IS curve come from? Well, let's just think of the simplest case. Let's suppose that we have closed economy, no government, and that identity is that y is equal to c plus I. Well, we can shift that around, and we can see that savings, y minus c, has to be equal to investment. So the point of the IS curve is that insofar as along the IS curve, output is equal to the sum of expenditures, it also means that investment must be equal to savings. That's where the name IS curve comes from.